increasing and decreasing function. So let's take an example y is equal to x plus 3. If you take y is equal to x plus 3 and plot the graph for x is equal to 0. Say x is equal to 0, so y is equal to, so x is 0, y is 3. Is it? Then you say x is equal to 1, x is equal to 1, so y is 4, so here it will come. X is equal to 2, so y is 5. So it is, you say that it is increasing function. Is it? You take 1, 1, 1, 2, 3. Is it? So it is degree, which is going to make a parallel, draw a parallel with x-axis. So you will get theta is equal to, near about it is, so you say assume that it is 45 degree. So whenever increasing function is there, the theta must be less than 90 degree. It is always will be less than 90 degree. And when what is increasing function? As x increases, if you substitute x is equal to 1, y will be 4. Y means what? Fx. So fx is also increasing. Is it? Okay. Take and compare this with the equation y is equal to mx plus c. If you compare, then you will get c is equal to 3, m is equal to 1. Slope of function is 1. Okay. 1 means, therefore we got m is equal to 1. M is equal to 1. Where tan theta value is 145 degrees. So this theta is become 45 degree. Is it? Because if you compare that, you will get m is equal to y is equal to mx plus c with this equation. You will get x is equal to 1, m is equal to 1, and this 3, c is equal to 3. So m is equal to 1 means slope is 1. When it is slope is 1, tan theta. So tan theta is equal to 1. What degree it is 1? 45 degrees. So therefore it is become 45 degree. So what is the increasing function? When x increases, f of x is also increasing. Is it? In this case, if you see x is increasing, then f of x is also increasing function. Is it? And now you take y is equal to minus x plus 3. If you put x is equal to 0, so y is equal to 3. Is it here? Then x is equal to 1. When x is equal to 1, what is the value? 2. So here. So it is a decreasing function. So what x-axis it make and what angle it makes? Okay, what angle it makes? It's make an angle of 135 degree. So what is when x is increasing? What is a y is decreasing? Y is decreasing means f of x is decreasing. So it is a decreasing function. And whenever it is a decreasing function, the value of theta is greater than 90 degree. Is it? So comparing this, what is increasing function? Theta is less than 90 degree. When x is increasing, fx is also increasing. Is it? And theta is less than 90 degree. When x is increasing, f of x, not f dash, f of x is decreasing. So it is a decreasing function where x, the theta is greater than 90 degree. Is it? Okay. Minus 1 means, what is, where is a tan theta minus 1? It is 135. At 135 degree, it is, theta is 90 minus 1 value of theta. So when x is increasing, fx is also increasing in increasing function. And when x is increasing, fx is decreasing. This is the simple definition of increasing and decreasing function. Is it? We understood this. Now let's say sine. Is it? Sine function. We know that is 0 to at pi by 2. At pi by 2, if you say it is sine 90 degrees, sine 90 is 0. So it means this is tangent. Tangent, if you draw at this point, tangent, it will be parallel to x-axis. When the tangent is parallel to x-axis, f dash of x is equal to 0. So what is happening interval wise? You say 0 to pi by 2. It is if you draw at any point on this curve between 0 to pi by 2. If you draw any point, the slope is increasing. See, is it? It's an increasing function. So it is increasing function. So 0 to pi by 2, the function is increasing, and pi by 2 to pi, it is decreasing function. You drawn like this. Is it? We done before. Drawn like this, it's a decreasing function. When you draw like this, it is increasing. When you draw like this, it is a decreasing function. You're drawn like this. From here you will draw. So it is a decreasing function. So until it will start decreasing, until it will decrease to 3 pi by 2. It will be decreasing function. From pi by 2 to pi to 3 pi by 2, it is a decreasing function. And thereafter 3 pi by 2 to 2 pi, it is increasing function. Is it? So from it is clear that whenever we talk about the function is increasing or decreasing, we talk about the interval and domain. Is it? Interval and domain is very much important. So what type of question can be asked in this? First, there are two types of question can be asked. First, state the function is increasing or decreasing in a given interval. And second, it is given that it is increasing, decreasing. You have to find out the interval in which the function is increasing, decreasing. So these are two types of function. Okay, two types of questions we can say. First one, the function is increasing or decreasing function in a given interval, or function is increasing and decreasing, it is given, but which interval that we have to find. So these are the two types of the questions can be asked. Is it? Again, here again we say in the interval 0 to pi by 2, draw a tangent at any point. Isn't at any point? Here we are drawn. At any point. Here also you draw. Here also you draw. You'll draw from here, this side. Okay, from starting from here to here. So it is increasing. Draw tangent at any point. The tangent, that is the slope of the tangent, is positive. And the tan theta is less than 90 degree. And this is positive. Is it? In the interval, say pi by 2 to pi, draw tangent at any point. The tangent is negative, theta is, you can say that it is greater than, not this, greater. Tan theta is greater than 90 degree, hence the slope is negative. Is it? If you say this is theta, if you draw the curve, here theta is 0. So what I say, it is parallel to x-axis. So f dash of x is equal to, can be equal to 0. Here f dash is less than, f dash is greater than. Is it? So let a function is increasing in the interval AB. Is it? So f dash x is greater f dash of x is greater than 0. F dash is a, what is f dash of x? F dash of x is a slope of a tangent. Is it? We say here, just simply draw a curve like this. Okay, from here to here. Take any point on this. Drop the perpendicular. What will happen? This theta will be less than 90 degree. The form, whatever it will form, it will be less than 90 degree. It means that f dash of x is greater than 0 and it is positive. Okay, and the slope is positive. And say pi by 2 to pi, draw a curve like this you draw. Take a curve like this, draw. Take any point, draw the tangent. With this is greater than 90 degree. Is it? Okay, and so it is will be f dash of x is less than 0. Is it? What we have said. Okay, the tangent is greater, this is theta is greater than 0, but the slope is negative. The slope is negative. Okay, here because it is a decreasing function. Now here, draw the curve like this. Take a point here. Draw it. F dash of x is 0 because it is parallel to x-axis. Is it? So let's take here curve. If you are talking about from here 0 to pi by 2 to 0 to pi by 2, but it is close interval. If we talk about 0 to pi by 2 close interval, f dash of x will be greater than equal to, because it is close interval. We talk about open interval 0 to pi by 2, then it is strictly, what is say, increasing function. Got it? Is it? Okay, increasing function. It is a closed interval 0 to pi by 2, function is greater than equal to, because at this point it is equal to 0. Okay, so if we talk about the interval 0 to pi by 2 open interval, the function is increasing. 0 to pi by 2 is greater than, f dash is increasing, but the f dash x is greater than equal to 0 and the function is increasing. If it is closed interval pi by 2 to pi, the function f dash of x is less than or equal to 0, because again it is 0 and then pi. Is it? Okay, so it is less than, greater than, equal to 0. Equal to 0 when it is closed interval. When it is open interval, it is 0 and pi by 2 is not including, so it is an increasing function. Now let's see what is strictly increasing and strictly decreasing function. So take interval a to b. First, this function is increasing from this interval. For this interval, the function is increasing from a to, say, a1. Is it increasing from a to this a2? It is, we say that it is parallel, and then again it is increasing. See, so this type of it is increasing function. F dash, in that case, f dash of x will be greater than equal to 0, because at one point it becomes 0. It is parallel to x-axis, then again is increasing. So f dash of x, this kind of graph, when it is given, we understood that it is increasing function, and f dash of x is greater than equal to 0. See, now strictly increasing function a to b, if you draw the curve like this, it is strict increasing. Strictly increasing means what? F dash of x is greater than equal to 0 in the interval a to b, in the open interval a to b. It is strictly increasing. It is not like that becomes 0. So whenever it is a increasing function, we have to prove that, we have to understand that f dash of x is greater than equal to 0. When it is increasing, strictly increasing function, then f dash of x is greater than 0. Is it? Same thing for decreasing function. When the function is decreasing in the interval a to b, is it? It become decreasing, then it become parallel, means equal to 0, then again it is decreasing. So the f dash of x is greater than equal to 0. So what we have to understand, that when the function is decreasing, f dash of x is less than or equal to 0. When function is increasing, f dash of x is greater than equal to 0. When it is strictly decreasing, strictly increasing means f dash of x is greater than 0. And when it is strictly decreasing, f dash of x is less than 0 in the interval a to b. Is it? Strictly decreasing. Okay, nowhere it becomes 0. The function is increasing or decreasing in the given interval. This is the first type of question. Suppose the question is given, prove that f of x is equal to cos x is first you have to prove strictly decreasing function in 0 to pi. Okay, and strictly increasing function in pi to pi by 2, and neither increasing nor decreasing in 0 to pi. Okay, so f of x is equal to cos x, the derivative with respect to x, f dash of x is equal to sin x. Is it? Now we have to see sin x, when the sin x function is there here, this is positive crust and trough is negative. You know this, isn't it? Learn in physics also. This is positive, this is negative. So what we say, since sine function is positive on the interval 0 to pi, is here you see 0 to pi, it is up crust, so it is positive. Okay, but f dash of x is negative, implies is that f dash of x is less than 0. Is it? Less than 0. So it is a strictly decreasing function. Okay, strictly decrease, not equal to, never it becomes equal to 0. So f dash of x is less than 0. How I know that it is less than 0? See, this is negative, this is positive. Positive into negative, what it gives? Negative. So f dash of x is less than 0. This is that. Okay, so when what is a function when f dash of x is less than 0? It is here. See here. It is a strictly decreasing function when f dash of x is less than 0. The function is strictly decreasing. So in the interval 0 to pi, the function is strictly decreasing. Proved? How we do it? First you have to take derivative and see that. And where is the crust? Crust is positive and trough is negative. Crust is positive. Is it? Since the sign is positive on the interval 0 to pi, we see where the interval is 0 to pi. 0 to pi is here. 0 to pi, whole. Got it? 0 to pi, it is whole, it is crust, positive. Positive into negative, so implies that f dash of x is less than 0. Less than 0 we got. Less than 0, what is emphasis? It emphasizes that it is a strictly decreasing function. Okay, strictly now f dash of x is equal to sin x. Since the interval pi to pi by 2, you see here, pi to pi by 2, it is trough is negative, it is negative, and f dash x is also negative, so negative into negative, positive, so f dash of x is greater than 0, so function is strictly increasing. Got it now? We have to see where the crust and trough lie. Trough, sin x is negative, and since the sine function in the interval, since sine you write, sine. Since sine in the interval pi to 2 pi is negative, so negative into negative, positive, so f dash of x is greater than 0. So function is strictly increasing. Understood first type of sum? Now, in the interval 0 to pi, the function is decreasing on 0 to pi. Okay, and increasing on pi and pi by 2. So the function is neither increasing nor decreasing. You see, the third question was asked here. Neither increasing nor decreasing in 0 to pi. Okay, we have to say 0 to pi or 2 pi. Is it? So it is not decreasing, 2 pi, maybe 2 pi. Okay, here 0 to 2 pi. So here it is increasing, here it is decreasing. So we can say that it's neither increasing nor decreasing in the interval 0 to 2 pi. Okay, now let's move on to second type of question. To find interval in which the given function is strictly increasing and is strictly decreasing. Strictly increasing means SI and strictly decreasing means SD. In the interval, find the interval in which the given function is there. So these are the second type of example. So f dash of x you find. First step to find f dash of x is equal to 0. So what value you will get? Critical point. Critical point x is equal to 2. X is equal to 2. Okay. For less than this, minus infinity to infinity. So you can also reduce it to 1, 0. For all this function, the f dash of x is less than 0. How? This is x is critical point. Left hand side, put x for 0. F dash is equal to become 0. So this all f dash of x is less than 0. And in the interval 2 to infinity, or we can say up to 4. Is it? Maximum 4. So 4. What do you get? F dash of x is greater than 0. So in the interval you can say minus infinity to 2. Okay. It is SD. SD means strictly decreasing. And 2 to infinity, f dash of x is greater than 0. Greater than 0 means what is it? It is strictly increasing. Got it? So we got the interval. What is the interval? Minus infinity to 2. It is strictly decreasing, and 2 to infinity is strictly increasing function. Okay. Suppose there is no, we can say. So suppose there is no critical point. Here we got critical point. How we got critical point? After taking f dash of x, first step, f dash of x is equal to 0. We got the value of x is equal to 2. So 2 was a critical point. Okay, now it is to second step is to locate the critical point on the number line. Is it? Or relocate, you can say relocate the critical point to, and like this. Suppose there is no critical point, then in that case what we'll do? Suppose there is no critical point, then suppose you take an example, f dash of f of x is equal to 7x minus 3. Increasing interval. Was it? So f dash of is 7. Now there is no, we cannot equate it to any function. So whenever there is no critical point, then we can say it is not a critical point. critical point, some value of x should be there. There is no x here. Is it? So we cannot equate to 0. It is a constant function. So f dash, in that case, f dash of x is greater than 0 for any value of r. So it is a strictly increasing function and theta is always less than 90 degree. Okay. Now second definition, these two definitions you have to learn. A function fx is said to be strictly increasing function on an interval a to b if x1, see here, suppose we say here, let's say 1, 2, 3, 4. So a is equal to, say 1, 2 and 3, 4. So b is equal to 4. A is equal to 2. So what is that? 2 is less than 4. So x1 is, this is called x1. x1 is less than x2. Is it? Then in that case, put the graph here on the curve. Let it draw the perpendicular on the curve here, and let us draw the perpendicular to touch the curve, and draw the perpendicular on y-axis x1, and this is x2. What it implies is, if x1 is less than x2, implies is f of x1 is less than f of x2, then the function is said to be strictly increasing function. Understood? Plot the graph here. This is 2. So obviously 2 is less than 4. So x1 is less than x2. And if you plot the perpendicular on the curve, and from the curve if you drop the perpendicular on y-axis, will give you f of x1. Same way, the perpendicular from the curve, okay, and then on y-axis you will get f of 2, f of x2. So here f of x1 is less than f of x2. So whenever it is that x1 is less than x2 in the given interval, implies f of x1 is less than f of x2, then we say that a function is strictly increasing function. And same way, a function is said, ff is said to be a strictly decreasing function on an interval ab if f of x1, again here we say a, minus 2, minus 1, and here 4. So x1 is less than x2. So this will be same. If a function is said to be strictly decreasing function on an interval, if x1 is less than x2, implies plot the graph. Where is here? Just plot the perpendicular here and drop the perpendicular on y-axis. Here it is f2. Drop the perpendicular on x-axis, and from the graph draw the here f2. So what you get? F of x1 is greater than f of x2 for all x1, x2 belongs to AB, and so therefore the function is strictly decreasing function. Okay, the function is strictly decreasing function because f of x1 is greater than f of x1 is greater than f of x2 for every x belongs to open interval AB, and therefore function is strictly decreasing function. Is it? Okay, understood? This you understand with the figure only. Suppose this is x1, this is x2, so it is minus 1 and 4. So naturally this x1 is less than x2. But what is f1? This may be 4, so this may be 2. So f1 is, what is that? It is f1 is, f of x1 is greater than f of x2. Therefore function is strictly decreasing function.